Hey, hello, hi everyone. So this is the lecture recording for part 2B. Basically, part 2B, like I mentioned in class, is more of examples. So we did not have time to go through all the examples in class. So this lecture, it's a mandatory lecture that you have to go through. But basically, we are just going through the examples on cash flows and also time value of money. Okay, so without further ado, let's carry on with this part. So 2B, right. So I'll just be going through the examples again. I'll show you the how to do it in Excel as well for the first few examples. And after that, we'll just go through the steps. Okay. So for first example, you think you'll be able to deposit 4,000 at the end of each of the next 3 years. Okay, so important to take note that it is the end. Let me just use my tool. Um, okay, so it's at the end, so you know that it is there's an ordinary kind of annuity, right, for the next 3 years, and it's going to pay you a 8% interest. Okay, you currently have 7K in your account. So how much will you have in 3 years, and how much will you have in 4 years? So we're going to use Excel to do this. Let me just switch over to my Excel screen. All right, so you should be able to see my Excel screen now. So the question is that we have, uh, let's just put in the cash flow, and then this is the, let's just put the discount rate. Okay, let's put it here. All right, so that's the year 0, 1, 2, 3, and 4. So the question say, so you have your lecture slides in front of you. So questions say that you have 7K in at the start, and at the same time, you're going to put in 4,000 for the next 3 years, right? So let's just put 4,000, 4,000, 4,000. So you don't need year 4, just leave it blank. Okay. So they ask you how much do you have in 3 years. So oops, this is 4,000. So one way to do it is that you can straight away do a FV, which is what the lecture slide showed you in the next page. You can have a look at it. But I would like to use this method to do an MPV method instead. So what do I do now? So I do an MPV. So meaning that, like we go through MPV, meaning remember MPV is you gotta put in the discount rate, which is here, right? Comma, and the values. And remember for MPV, you exclude the year 0 values, okay? Plus, and you plus the year 0 inside, from outside the formula like this. Okay, let me just put in my discount rate at 8%. I can put this as a percentage, so it's nicer. All right, so this is my MPV, but the question say how much do we have in 3 years, right? So in 3 years means that this is, remember, this is the present value, right? Your MPV, MPV. So this is the present value. So you discount all your cash flow back to um, the year 0, the start. So now the question was in 3 years, right? So very easy. Once you have your MPV, you can simply, so let me just put in 3 years. So I just simply take this one, multiply by my discount rate, and I power it to how many years? So in 3 years. Sorry, I need to add 1 plus. And so you see, you get your answer in your slide, which is 21, 803, right? So in 4 years, no issues with that. So basically it's the same thing. I'll just need to take this, right, times 1 plus the discount rate and power it to 4. And there you go. You get 23,548 or 547.87. So this is the MPV method. So if you don't want to do an MPV method, you can do the FE method, which is shown in your slides. So let me just stop sharing this. And I'll continue sharing the slides to have a look. So this is the question. Oops. So this is the FE method, right? So in the FE method, you can also create a table in your Excel, and from there you just multiply the discount rate 1 plus the discount rate by the number of years, right? Because you're in 3 years, you just multiply by 3. Then for year 1 multiply by 2, and for year 2 to the power of 1, and then of course for year 3 you just leave the value as this, and then you total up, you get the same answer. And in year 4 you just multiply this one by one more time, right? One more time meaning the 1 plus the discount rate again, and you get the year 4 answer. So the method that I showed you earlier is just a different way of doing it. I think it's a bit faster, but it's up to you. Okay. All right. Now let's move on to example 2. So example 2 here says that you're offered investment that will pay 200 in year 1, 400 in next year, 600 in the following year, and 800 in the 4th year, right? So you can earn a 12% return, okay? And what is the most you should pay for this one? So what's the question asking you? What's the most you can pay? Meaning that what is the MPV of this cash flow, right? So for this investment plan, imagine it's an investment plan, right? So I'll just show you one more time to do it in Excel. Again, let me just share my screen. Okay, so I'm sharing my Excel screen now. So the question says that the for year 1, right? So of course year 0 is nothing. So year 1 is 200, 400, 600, and you have a year 4, which is 800, right? So let's just put year 4 here, and you can earn a 12%. 12%. Now let's just delete all this so we don't get confused. Okay, so now we can do an MPV, but remember to add this in. Again, of course, year 0 is 0, so it's nothing. So the formula works fine, and can you see straight away you get an answer of 1432.93. Okay, so this one is a 0. Let's put 0 here for year 0. So this is the answer for example 2. Okay, so in example 2, I think the slides also show you how to use the MPV function. Okay? I just want to repeat again. For MPV, remember that your formula's cash flow starts with year 1. So that means if there is some cash flow in year 0, you will have to put it outside the MPV formula like this. Okay? I want to repeat again now, you have to put it outside the MPV formula. So in case there is some cash flow, like for example in example 1, I would like to repeat that you have to put it outside the MPV formula. All right, this is very important. Okay, let's look back at the lecture slides. Right, now example 3. Now for example 3, I'll not show you the Excel because it's quite similar, but I'll just go through the example. So let's see what are the key points. Okay, so it starts off year 1 at 100, year 2 and 3 is 200, okay, and 4 and 5 are 300. Discount rate is 7%. Now they ask you what's the value in 5 years and what's the value today. So my immediate instinct of what I'll do is I'll do an MPV again. Remember, so So try to do NPV because you see the second part is actually today, right? So if you do the NPV, then what you can do is you can shift all the cash flow to year 5, right? By putting 1 plus the discount rate to a power of 5. So let's have a look here. Okay, so the solution is that you can either, what they provide you is either you NPV everything and then or you FV everything, right? But it'd be better to just do one of the methods. Um, so in this Excel here, they actually manually input all the various formulas inside here to a power. So basically you bring everything to for PV, bring everything to year 0, right? So and for FV you raise the power up for the 5 years. Okay, so you know what? Maybe for example 3, I'll show you again in Excel since this solution did not provide you the fastest method to do it. Let me just switch back to Excel again. Let's see. All right, so let's just put our 7% here. I want to move this down. I have 5 years. I will start with 100, 200, 200, 300, and 300. Okay. Now I will go into NPV everything, right? And can you see straight away you get your PV's answer, which is 874.17. Then after that, you need to FV, right? So you already answered the second part of the question. Now the first part asks you for what is the cash flow value of cash flow in year 5, right? So year 5, basically what you can just do, let's say in year 5 is just take this one times bracket 1 plus the discount rate, power it to 5. And so you should get the answer as per the lecture slide, solution FV. So I would highly recommend to do this because it's faster rather than doing what the lecture slide recommend of manually doing the FV and PV. Okay, let's go back to the lecture slide. Okay, example 4. Now, this is a standard PV function kind of question. So, you can afford 632 per month. Okay, so important to take note, remember, when we have this kind of question is all the base must be the same. Meaning, if it's all months, everything should be months, right? If it's years and months, you should convert it to the months, right? So, always bring it lower, right? As in make it to a smaller unit. So if it's years and months and you know that at the end of the day you want a month's kind of answer, bring it down to months. Later we have some example to have a look. So for this one, it's in months, so everything is good, all in months. So you can afford 632 per month. The going rate is 1% per month. That's good for 48 months. Very good as well. So how much can you borrow, right? So you know that the rate is in months, so no problem. You just put 1% inside your Excel. And then number of periods, NPER, number of periods is 48 because there are 48 months. Your payment, right? Remember the convention about when it's negative and when it's positive because it's important, right? So when money is going out of your pocket, it is a negative. When it's going into your pocket, it is a positive. So what's this now? You are actually borrowing money at the start, right? So meaning that every month you have to pay, right? So you can afford. This is meaning payment, right? You are paying. So this is a negative. So that's why it's a negative 632 for payments. Okay. Of course, because you're borrowing money, at the end of the day, you must return all your money. So you have 0 for FV. Again, type, this is an ordinary annuity. So type is 0. In your Excel formula, I repeat again, you don't have to put the 0, but it's a good practice, right? Just in case you stumble upon an annuity due kind of question. All right, so now you just compute PV. So you just input all the numbers into your Excel formula for PV, and this is the answer you should get. So the present value is 24K. It's a positive. You notice a positive. Why? Because remember, you're borrowing money, so the money is going into your pocket, meaning that it's positive to you, right? Remember, money going in is positive. So it makes sense, right? So your payment is negative, and your PV, which is money going into your pocket because you're borrowing money, is positive. So perfect. The convention works. Okay, so this is a simple example for. Now let's look at another example for this sweepstake. So basically, this example is about you know, you're supposed to win this like kind of lottery, which is 10 million lottery, a lot of money. But this thing about this lottery is that, okay, the money is being paid on equal annual, okay, it's per year, annual installment of this 333.33 for 30 years. So again, remember, when we look at the units, everything's in years. So that's good, right? So the base is years. So this 5% obviously is a year as well, if you're not mentioned. Unless it mentions a month, then you need to take note of it. So now the question asked is, how much does this sweepstake actually worth today? So today immediately tells you that the question wants you to do a PV. Okay, you want to do a PV here. And because they are not paying you 10 million straight away, right? They're giving you this 333.33 over the whole 30 years, meaning that you're actually getting less. Remember your idea of time value of money, right? You want to get money now, right? If you get later, means that you're actually getting less because the sum that you receive now, you can actually invest it to something more. Okay, so you can just plug in the numbers. Rate is at 5%. All right. Your MPR, which is number of years, you have 30 years, so no problem. Your payment. Now remember, you're receiving money now. Remember, you're receiving money of 333.33. So these payments are all positive because money is going into your pocket, right? Now, your FV is 0 because at the end of the day, they pay you the installment, right, for 30 years. Then at the end, they're not going to pay you anymore, right? This is 0. Okay, type is 0 as well because it's ordinary annuity. And now you calculate that your PV, right, is actually only 5 million. It shows that actually instead of winning 10 million, you're only getting 5, or just slightly above 5 million, right? Again, one more thing. What's this convention? This convention is in the negative, right? So why is it negative? Because this is basically asking you, actually, how much should you, how much does this yearly installment worth, right? So actually worth 5 million. And obviously you're not getting 5 million now, so actually it's negative to you. Okay. All right, let's go on to example 6. Let's change the color. Okay, so example 6, right? So you want to receive 5K per month for retirement. Okay, you earn 0.75 per month again. All right, that's good. Now, and you expect to need the income for 25 years. Okay, remember we just now talked about how we need to convert the base into a smaller base, meaning that if it's years and months, we always convert it to months. So in this case, these 25 years will have to be converted into months. Please take note. So how much will you have in the account at retirement? Meaning that you calculate your PV again. All right. So the monthly rate is fine because it's already in months, right? So it's 0.75% or 0.0075. Please just be careful of the number of zeros here. All right. Now, number of periods, MPER, is 300. How do you get 300? You just take 25 times 12, right? Because you have 12 months in 1 year. So you get 300. Now, monthly payment, it is 5,000 per month. So it's fine. Don't need to change anything. Don't need to divide by 12 or times 12, whatever. Don't need. Okay. Of course, you want to receive money, right? So it's going in your pocket. So it's positive to you. Now, FV, of course, is again 0. Type is 0 because it's annuity. And then you get this compute of PV. So how much do you need to have in your account for this retirement? So that means this is the amount, this close to 600K must be in your account, meaning you're taking the money out of your pocket and putting it in the account, right? So it's negative. So this makes sense. This is a negative value. So remember, at the end of the day, whenever you do questions, right, always try to rationalize the negative and positive. Does it make sense to you? Is it money going in or out of your pocket? All right. Now, let's go on to example 7. Another example, but now what we are looking at. So we want to calculate now the number of periods. Why? So they say that they have 1,000 due on a credit card. Okay. And then what does this mean? So that means actually you're getting this, like, remember, a credit card is like a loan, right? So that means the credit card company is giving you this 1,000 first. So it's like a loan to you, right? So this one should be a PV and it's a positive value because the credit card company is like giving you this 1,000 first, right? Then of course you have to return the 1,000 later lah. So your FV will be 0. Okay. So then therefore you know that your FV should be a 0. Now payment is in months, $20 minimum. So you need to pay minimum. And remember, payment you must pay, so it's a negative. All right. Then rate is 1.5% per month. So it's already per month, so it's good. It's all in months. Very good. And so there's this reminder here, convention matters. But then again, I want to remind you that for all questions, just be very clear when it's negative, when it's positive. So you don't need to worry like when does this negative and positive matters, right? Once you know about the money in, money out, you will be able to get an answer. All right, so now we're going to calculate the number of periods, right? So you know that your rate is this 1.5% or 0.015. All right, your payment is negative because you need to pay minimum of 20 per month, right? Your current so-called loan or credit card amount that is due is 1K, right? PV 1K. And now at the end of the day, you know, when you pay off all your credit card, your final value FV must be 0. Type is 0 and then you just compute. But I want you to take note that when you plug in the value, this answer here will be in per month. So you have to convert it back to years because, you know, depending on question, okay, this question is not very clear whether you want they want answer in years or months. But let's say in the exam, they ask for the answer in years. So if you don't convert the months to years, you know, you probably lose 1 mark or maybe 2 marks depending on the number of marks in the question. So just take note that at the end of the day, when you calculate, since everything here is in months, so your answer, right, number of periods will also be months. So just take note that you should convert back to years because usually question wants it in years. Okay. Now let's go to example 8. Suppose you borrow 10K for your parents. So borrow, remember, money is going in your pocket, right? So it's a positive again, just a reminder. To buy a car, and then you agree to pay this one per month. So payment is a negative, all right, for 60 months. All right. So what's the monthly interest? So everything is in months, so it's pretty good. So your number of periods is 60, your payment, remember, is negative, so it's 207.58. Remember, your NPV, your PV is positive because you borrow the money. At the end of the day, you must pay off your parents, so it's FV is 0. The type is 0 because, again, it's an ordinary annuity. And so you simply just plug in your various value inside your Excel rate formula, as you can see here, and you should get this 0.75 per month. Okay, so remember, what is this rate? I hope you remember what is this, right? This is your period rate. Remember, period rate is your APR, annual periodic rate, divided by number of period. Okay, so this is your period rate. Later we have a question on the difference between period rate and then your effective rate as well. So period rate or periodic rate. Okay. Now let's go to example 9. So you want to receive 5K per month for the next 5 years. So how much would you need to deposit today? Right. So today is like a PV question again. If you can earn 0.75 per month. So everything's in months. Just take note that for next 5 years, so these 5 years should be converted into months, remember, because you want to bring it down to the lowest base. So it's a PV question, so your rate is this 0.0075 or 0.75%. All right. Your number of periods, which should be in months, so you need to convert it, is 60. Your payment, or which is what you want to receive, right, per month, is 5K. So receive is positive, right? So I'm going to put positive here to remind you. Of course, at the end of the day, there should be nothing left, right? So F is 0, type is 0, no difference. So they ask you how much you need to deposit today. So actually, you're depositing money into account, meaning the money is going out of your pocket. So it's a negative to you, which makes sense, right? So when you plug in all these values, you get 240,867. So that's the answer. All right, let's move on to example 10. Suppose you begin saving for your retirement by depositing 2K per year. So you're depositing money. This is a negative in this IRA, which is the kind of account. If the interest rate is 7.5%, this is in years, no problem. How much do we have in 40 years? So this is a very standard kind of FV question, right? How much do you have in 40 years? So you have your rate, which is 0.075 or 7.5%. Okay, I just want to remind you that in Excel, remember that you need to convert your percentage into the actual number, meaning that if it's 7.5%, you should put in Excel as 0.075. Okay, very important. I highlight this again. You have to put it. Let me just can I do a highlight here? No, I can't do a highlight. Okay, but just take note about this, that you need to put it not as a percentage. So put it as 0.075. Number of periods is 40. Okay, because you have 40 years. And then your payment, which is what you're going to deposit every year, is 2K, which is negative, makes sense. And then same thing, PV type is 0, no difference. And then you calculate your FV. So your FV is positive. Does it make sense to you? It does, right? So how much do you have in 40 years? So basically you're putting in money every year, right? And then at the end of the 40 years, you have a lump sum in your wallet. So it's a positive to you. So this makes sense. All right. Now we have a question on growing annuity. So recall that your growing functions, right? Growing, especially like growing annuity, does not have a calculator or Excel function. So you need to use the formula. That's the best way to solve the question. Okay. So given that year one cash flow is 1K, suppose you expect to receive this cash flow that will grow at constant rate at 4% uh, from year one up to 4 years. So year four lah, right? So what's the present value of this growing annuity if you require a required rate of 8%? So this is a very direct kind of growing annuity question. So what do? So you simply just plug in the values inside of this growing annuity formula. And remember, this growing annuity is a ordinary annuity, right? So you plug into a growing ordinary annuity formula. Okay, if you remember, if it's a annuity due, you have a different formula, right? So recall that. So basically, your constant growth, your 4% is a G, right? Rate of return, this is your R. So you just plug in the values as such. You put in your T is up to 4 years. So this is T is 4. So you just plug it in and you should just get the answer here. So this one you need to use your calculator or even Excel, you can solve this formula. Okay, this is the best way to solve it. There is no special Excel way to solve this question. All right, now let's go to an annuity due question. So whenever there is an annuity due, all right, to repeat again, in your Excel, your type should be 1, right? And if you're in Excel, you're doing ordinary kind of annuity, you can actually omit a 0, but it's a good practice to remind yourself that it's an ordinary annuity. If not, you should put 1, okay, as an annuity due. So now this question says you are saving for a new house and you put in 10K per year. So remember, you're putting in money, so it's a negative to you, right? 8%. Your first payment is made today, right? Once you see today, it is a due. So whenever I do questions, I would like to encourage you to highlight certain keywords and write it down to remind yourself that, okay, today means due, putting money means negative, like what I'm doing here to show you, okay? So how much do we have at the end of 3 years? So this is a FV question, right, at the end of 3 years. So your rate is 0.08 or 8%. Your MPER is 3 because you have 3 years. Your payment is negative because per year you're putting in 10K. All right. Your PV, of course, is 0 because you have nothing at the start. And the most important is let me just use blue, your type. Your type is 1. Okay, because it's annuity due. So you calculate, you just simply compute FV, and you should get this answer. All right. Now let's move on to example 13. So example 13 says that you want to have 1 million to use for retirement in 35 years. All right, you can earn 1% per month. How much you need to deposit on a monthly basis, right? If your first payment is made in 1 month, so this is a ordinary annuity, which is what I've written here, ordinary annuity. So it's not not annuity due. So remember, for ordinary annuity, your type is let me just write it down here. Type equals 0. All right. So this standard question. So remember, everything's in per month, right? So your 35 years, this one should be 35 times 12 because you need to convert your years into months. All right, important take note. So your rate is 1%, which is 0.01, no problem. Your NPER is 420. Your PV, of course, at the start you have 0 because you're saving money, right? You're saving money to get 1 million, right? So PV is 0, and at the end of the day, FV at the end of 35 years, it is 1 million, and this 1 million will be in your pocket, right? So it's a positive to you. Okay, this is positive. Type is 0, that's what we talk about. And so this is your payment, which is negative. Makes sense because this is the money you're going to put in, right, every month in order to save up 1 million at the end of 35 years. Actually, it's not too bad. You just need almost $200. So, maybe if you start early, you can be a millionaire by in 35 years' time. All right, now let's go on to example 14. So suppose you earn 1% per month on a $1 investment, on $1 invested today. So what's your APR, right? Annual periodic rate. So remember your formula. Your period rate equals to AP. Sorry. Let me just erase this. Equals to your APR divided by number of periods, right? So what is your APR or nominal rate? Remember, this is also called a rate norm, right? Or nominal rate. So what's your APR? You simply take the number of period, which is 12, because per month, right? So number of period is 12 times 1. So this is not too difficult. So next thing they want to calculate what's your effective, right? How much are you effectively earning? So very simple, effective. Just use this effective rate formula in Excel and just input the number of periods as 12 and input this is your APR, and you should get this. So it's slightly more than 12%. All right. Alternatively, you can use the effective rate formula, but I recommend that since you have Excel, just use Excel. It's easier. All right. Now, move on to example 15. Suppose you deposit 50 per month. So deposit money is coming out of your pocket, right? So it's negative. I just want to mark down this. Your APR is 9%, okay, based on monthly compounding. So how much we have in your account 35 years? So remember, now can you see that you have months, and APR is obviously in years, and you have the question is how much you have 35 years. So remember, I repeat again that you have to convert everything to your base, the smallest base, which is in this case months. Okay, very important for your take-home assignment, even your exam. Let's remember this, that you have convert it to the smallest base. So what do you do? So remember your APR, you need to find your periodic rate, right, or period rate. So you must take 9 divided by 12, which is what is done here. Okay, now number of periods, you have to take 35 times 12 because this is years, so convert everything to months, right, which is what is done here. Now your deposit per month, this is fine, so I just want to say that this is okay. So you just put 50 here, or negative 50 because it's negative. PV and type, nothing much to say. And you finally calculate your FV. So how much will you have your account in 35 years? So it makes sense, it's positive. So this is a positive value. Makes sense because it is what you have in your pocket after 35 years. Okay, so very important again, I repeat one last time that you need to make sure your base, whether it's months or years, are standardized, and always convert it. If it's there's years and months, always go to months, right? If there's months and days, go to days, because always convert to a smaller base. All right. Okay, now let's go to example 16. Now this is a car loan question. So we have this hire purchase act in Singapore, and you can borrow 50K for 3% for 5 years. So now I think the question we want to find out actually what is the actual interest rate that you are paying, right? They they're interested in like, is it really 3%? So now let's find out. So the amount of interest they pay for 5 years at 3% is this, right? This is a very simple interest kind of payment. So you just simply take 50K times 3% times 5. So this is the total interest they pay. So your what does this mean? So actually your monthly payment, right, is your principal plus your total interest divided by 60, right? 60 is you just take 5 times 12, right? So every month you are supposed to pay almost 1K, right? 958.33. Now, you are actually interested in find what's the periodic rate. So let's just plug in the values in using the rate formula in Excel. So you have 60 as an MPER, your payment, right? Because remember you're paying for this loan. So the payment is at almost 1K or negative 958.33 as payment. Your PB is what you borrow now, so it's positive to you, right? So imagine you're getting this money first, so positive. But FV is at the end of the day, your FV is zero because you need to pay off your loan, all right? Type zero, no difference. And you calculate that actually per month, this is your periodic interest rate, period rate. Now, because we want to find out, we want to see the actual interest, right? So we are actually not so interested in the periodic rate, but what we're interested in is your effective rate. This is the reason why we need to calculate effective rate, because we want to see actually what is the effective rate you are paying. So remember that one's periodic rate, right? So you need to convert your periodic rate into your APR, right? So you just multiply by 12, you get this. And once you calculate your APR, the next step is to use your Excel formula to calculate effective. So what happens now? Can you see that the effective rate you're paying is actually 5.79% instead of the 3% that is being advertised for your car loan? And this is actually very common in if you drive a car or motorbike, it's very common. So now that you know this, you should remember to always calculate your effective rate when you take a car or motorbike loan. Okay. Now let's move on to example 17. It's a short one. So which rate should you use to compare alternative investments? Please use the effective annual rate because different alternative investments might have different horizon. Horizon meaning different number of periods. Maybe one investment is 3 years, one investment is 5 years. So you convert to everything to effective, meaning that you are comparing it as if it's a 1 year basis. So you can easily compare. Okay. Which rate should you use for time value of money? Of course, use your APR. You don't use effective, right? Now, let's go on to this example 18 on a T-bill. Remember, T-bill is like a bond, right? A short-term account bond. So the thing is, this treasury bill is excellent example of like a discount loan, meaning that you're actually receiving the full loan amount at the end, which is a FE, like so it's like a bond. Okay, so let's look at this example. T-bill promised to repay in 10K in 12 months, and the market interest is 7%. So how much will this bill sell for the market? So at this point, maybe I want to repeat again what is a bond. All right, so a T-bill is a short-term bond. So what is a bond actually? So remember, a bond, it is like me, okay? So I have some extra cash, right? And I don't mind lending this cash out to somebody. So what happens is that I will pass this money to the company, right? And this money is 10K, pass it to the company. And what does the company do? The company will give me a paper, and this paper is called bond. Basically, this paper represents an IOU, means the company owes you 10K because you actually give the company 10K, right? So at the end of the, let's say for this one is 12 months, at the end of 12 months, the company, you must take this paper and give back to the company, and then the company return you the 10K. Okay, but then the question is, where is the interest, right? Now, a bond is interesting because the interest comes in annual periodic payments, right? Which is what we are seeing here. That you might actually get annual periodic payments. Okay, but this for T bill, there is no periodic payment. Okay, so but in a bond, normal bond, there will be periodic payments, and that will be your interest. If there's no um, periodic payment, then the cost of the bond should be lower than what you lend the company. Why? The difference amount. Can you see that? Okay, imagine you have already calculated, right, that this is the cost 9346. Means that you're actually giving the company 9346, right? Around 9,000. And later, after 12 months, you receive 10K. Can you see that you're actually receiving an interest? Right? So it's a different sense, right? It's like you're receiving an interest, but it's just not in a periodic sense, right? It's just at the start and the end, because this is very short term. So there's no periodic interest given to you. But in a normal bond, there will be periodic interest, meaning payments. Okay. Please take note that this is a typo. This is not PV, it's PMT. Yeah, it's PMT. It's a wrong one. Okay. Okay. So in this example, you have interest rate of 7%. So you put rate at 7% because now how much will this bill sell in the market, right? So it's a PV question. So number of periods, 1. Okay. And then your payment is 0 because you're not paying anything. Your FV, remember what you're going to receive back, right, is 10K. So now the question is, of course, type is 0. So now the question is, what's your PV? So PV is 9346, which is how much you are going to give the company for this paper, right? So that, can you see that? I repeat again, there is a growth of your money from lending only 9346, and then you get back 10K at the end. 10K. Okay. Now we have this question about amortizing loans. So amortizing loan, I want to repeat that it's very easy to do it on your Excel. Remember, create an amortizing table. How do you do that? Okay, let's see this example. You have this amortizing loan for 4 years with annual payments. Your interest rate is 8%. Your principal is 5K. What's the annual payment? So the first step to doing amortizing loan is calculate what's your payment, right? So how do you calculate payment? So you know it's a 4-year loan. For rate is 8% or 0.08. Your PV, right? Because you're getting money at the start. So PV is positive, makes sense because money is going to your pocket. But at the end of the day, FV must be 0, meaning that you pay off all your loan. You repay your loan, right? So you at the end, no loan, so 0. The card is 0, meaning that your payment is negative. Correct, ma? Because every year you have to pay, right? So it's negative. Makes sense. So payment is how much you have to pay every year. So it's 1510. Okay. Now, after you do this, you create your amortizing or amortization table using Excel. Very easy to calculate or to create based on these 3 key formulas and your payment. So remember that payment amount always stays constant. So it's 51509.6. Of course, beginning of the loan is 5K, right? Beginning here is 5K. Let me just reduce the a bit smaller. Okay, 5K. Total interest. So how do you calculate total interest? So here is the formula here. You just take beginning balance times your interest rate amount, 8%. So it's 400. All right. And then your principal paid. So principal paid is basically take your this one. So total payment minus interest paid. So you just take this thing minus your interest. This is your principal paid. And what's your ending balance? Ending balance, you just take the beginning balance, which is 5K, minus the amount of principal that you have paid, right? Which is the formula here. And you should get this amount here. Okay, so what is happening here? Do you notice, this is a repeat again, do you notice that your interest amount that you are paying for this amortizing loan decreases over the 4 years, and your principal paid increases over the 4 years, meaning that you're actually paying more and more principal payments and less interest payment, right? We recall your lecture slides on that that's called grafting, which shows the decreasing trend of your interest and increasing trend of your principal amount that's paid. Okay, so in the end, you should do this amortizing table. I highly recommend that you uh, practice at least once on creating this amortizing table in your Excel. Now we have a question, example 20, on um, buying a flat. So we have quite a lot of information here. All right. So you have the cost of flat, the funds available for down payment and closing costs, which is your stamp duty and lawyer costs, which is so how much money you have saved, which is 80K. Your stamp duty, how much your stamp duty, your down payment based on the loan to value or LTV, which is very common. So how much down payment must you pay based on the flat that you want to buy? All right, your annual salary, you have your so at the moment you have your monthly car loan as well. You have your total debt servicing ratio, which is 60%, meaning that how much of your income can you use to service debt. So meaning that you only can use 60% of income to service debt. The rest you have to spend on like expenses, savings, etc. So only 60% of income. And your interest rate for 30-year fixed loan is 3% per annum. Okay, so you have two parts here. The question is, how much will the bank lend you? And the second part is, can you afford to buy the flat? Let's tackle these two parts are actually very distinct, right? They are not related. Let's tackle the first part first. Okay, how much will the bank lend you? So you have a monthly income. You have a yearly income of 48K. So what's your monthly income? Your monthly income is 4K, correct? Your monthly income is 4K. Okay, what's the maximum loan? Remember, we have this, let me just flip it back. Remember your LTV. So what is the maximum, sorry, not LTV, your total debt servicing ratio, this one. Remember, what's your maximum income that you can use to pay loans? That's 60% only of your income. Okay, so 60% of income, meaning that is 4K times 60, so only this amount can 22,400 can be used to pay loans. Okay, now given that you have a car loan, remember, of 800 you pay per month, right? So the maximum available funds for your housing loan is only 2400 minus 800, which is 1600 for your housing loan. Okay, you know that your monthly interest is remember your yearly interest is 3%. Let me just flip it back again to show you. Remember your 30 years fixed rate loan is 3%, right? So what's your monthly? Your monthly is 3% divided by 12, which is 0.25%, and you simply calculate your PV. So this one I'm using the PV equation, but you don't have to do that. Remember, you can use your PV function in your Excel to do it. Okay, so you should get the answer 379503. All right. I think I didn't show you how to do plug in the values in Excel. You know what? Let me just share my Excel. and show it to you quickly is no difference from the rest of the PV questions that we have done so far. Okay, so now let's pull out your PV function here. Okay, what's the rate? You can just type in the rate 0.0025 because it's 0.25%. Okay, number of periods, we are looking at a 30-year period, right? 30 year, remember everything is converted to months, so it's 30 times 12, which is 360. Okay, your payment that you have to make on every month is 600, right? Your final value FV, of course, it's 0, right? Because no more bank loan. So you are calculating how much bank loan you can take, right? So at the end of the day, you should have no more bank loan. Your type is 0. So voila, that's your answer, right? You can actually take a loan up to 379,503.10. So what does this mean? This means that this is the amount that the bank will loan you, which is positive, right? Because money going into your pocket. Makes sense? Perfect, right? Okay, let me just switch back to the lecture slides. All right, so now let's continue on the second part of the question. Second part of the question is, can you afford to buy these flats? Remember when they ask you, can you afford to buy this flat, we have all this information here, which we need to use now. Okay, this one here. So now let's calculate what is the LTV, right? How much down payment must you make for your house? So they say you need to make at least 20%, right? So down payment value is 80%, means that you must pay at least 20% out, which you take this one, 450k times 20%, right? You get 90k. Now you need to pay stamp duty as well, right? How much is stamp duty in the question? Stamp duty is 3%. Okay, so 3% means that you have to take the cost of the flat, which is 450k times 3%, you get this. So your total house, right? So total amount that you pay initially is what? It's actually 90 plus 13,500. So this is the amount that you have to pay initially. Now, going back to the question say that you have available funds of 80k only. Means what? Can you actually make this payment? No. Can you see that you need 103, 500, but you only have 80k. So you are actually short of what? Almost 23,500, right? So can you buy this house? No, you cannot buy the house. That's how I answer this question. All right, I think this is the final example, and this example is about inflation. All right, so let's read this question carefully. So I just want you to take note that in the exam, if this question do come out, the diagram here that is drawn, right, is usually not provided. This is, I actually drew it on my own for explanation purpose. So you have to read the question very carefully, try to draw a diagram so you can understand the question better. All right, okay, so you have this, Rachel, age 30, plan to retire in 30 years. Okay, so I already marked down on my timeline, right, that this person is 30 and she plans to retire in 60, right, 30 years. Enjoying inflation adjusted, okay, this is very important, inflation adjusted sum equivalent to 30k per annum today. So that means she wants to, okay, now she's age 30, right? She has 30k. She wants to enjoy this 30k 60 years later. And for how long? For 20 years, because she wants to live until 80, right? So at age 60, she wants to still enjoy this 30K worth money today, meaning that you need to adjust for inflation already. Okay, so how much would Rachel need to save annually for her retirement fund? Okay, so they give you two rates, uh, investment rate or rate of return 6%, and inflation is 2.5%. Okay, once you see an inflation question, straight away think about your Fisher equation. Fisher equation, remember, is to convert your your nominal rate to real rate. All right, so plug in your values for your nominal rate at 6%, plug in your inflation of 2.5%, and calculate your real rate. So your real rate is this amount. Okay, so this is not too difficult. Now, why I put um, 1, 2, 3? So there are 3 steps to do this question. Let's go to step 1. I'll stay with step 1 first. So step 1, remember now she's age 30, right? And she only plans to retire 30 years later, in 30 years time. So how much will her 30K, and she wants to spend 30K 60 at age 60, and this 30K should be adjusted for inflation, meaning that obviously amount might be, it will definitely be more lah, because there'll be inflation because things keep on increasing, right? So the amount that she need to have in 30 years will be a lot, and this is quite easy to calculate. So it's just a FV kind of question, right? So you just take 30 times 1 plus 2.5% to the power of 30. What am I doing here? Meaning that I'm actually finding the FV of 30K in 30 years. Okay, I repeat again, I'm finding the FV of 30K in 30 years. All right, so what does this mean? So that means at age 60, she need to have 62,927K per for that year in order to still enjoy 30K worth of goods and services today. Okay, now, so let's go back to the diagram here. So can you see I put in 30K here? This is the today. And then at age 60, she cannot only have 30K, she need to have almost double. She need to have 62,927K in her pocket in order to enjoy 30K worth of goods and services today. Now, let's go to number 2. So, what happens now? So, we want to find out, because the question, right? That means let's go back to the question. The question says, how much does she have to have annually for her retirement fund? Okay, remember that she will live for 20 years, right? So this 62 is basically your annual payment that she will receive, right, from this lump sum that she saved, right? Every year she will receive 62927, all right, and for 20 years. Okay, now why do you have to use this real rate? Remember, because there will be inflation, right? Even from age 60 to age 80, right, the inflation will keep on continuing at 2.5%. Meaning what? You have to use the real rate instead of the nominal rate of, what's the nominal rate? Of 6%. You must use the real rate. Okay? I'm going to change color. So please use the real rate of this amount, and then you input every type, no difference. So you calculate that you actually need almost 1 million. So 900, so 901,292 amount inside your account at age what? That means this 900, right, it is at age 60. So at age 60, you need to have this amount in your account in order to withdraw this amount adjusted for inflation every year for 20 years. All right. Okay. So this is, we tackle part 2 already. We discount the cash. Okay. Now, part 3, because the question says how much does she have to save annually for a retirement fund, right? Annually, meaning that how much must she save from age 30 to age 60. So now we have already adjusted for inflation for the from age 30 to 60, 60 to 80. So adjusted for inflation rate. So you don't need to worry about inflation anymore. So what is the yearly saving she has to make now in order to save up for the inflation adjusted FV, right? Which is what the FV is, this amount that you calculate, right? So you don't have to adjust inflation again. Your rate, you just give the nominal rate. Your number of periods 30, right? Because she's saving from age 30 to 60, right? Your PV, of course, now she has zero money, so 0. Your FV is what she wants to have, right? So what your type is 0, and then so what you're interested in calculate? Your payment. So how much must she save? So okay, so a small typo, your FV should be positive, because this is the amount that she wants to withdraw at age so how much you want to have in your pocket at age 60. So your payment will be a negative. Sorry, let me just erase this. Your payment will be negative because it's how much you have to take out of her pocket, right? So this should be a negative. Small minor mistake. Should be a negative. So how much must she take out of her pocket every year for the next 30 years from age 30 to 60. All right. So it is 11,400. That's the amount I get. So that is how you solve this question. And this is the last question for part 2B. Thank you for your time.